Hi, in this video I'm going to be outputting the tiny essay, measuring the tiny essay output on my Rigol 804. So let's see if I first turn it on. Goes to the boot menu. There you go. This will take a little time, but once it starts up, it's ready for measurement. Now I'm going to be opening up my tiny essay. This is my tiny essay that I purchased a while back. This one is just the tiny essay, it's not the ultra. I couldn't find a market, I couldn't find a price or source where I can do a tiny essay here in India. So this is the older model. Yeah, now that the Rigol is booted up, I'm going to be connecting my tiny essay to the oscilloscope. Mind you, the tiny essay is basically SMA connections, so you'll be needing one of these BNC to SMA adapters. Well, let me open that up. Next we're going to do, I chose this one. This is the SMA female to BNC male. Let's see if it fits. Yep, there goes. I'm using channel 2 right now, just for kicks. Let me turn on channel 2. Yeah, we got no signal on that. So now let's hook up the tiny essay to the oscilloscope. There you go. That's tight. So I'm going to be using channel 2 on this oscilloscope just for kicks. Just to let you know, I can use channel 1 or the other channels too, but this is much more. Now I turn on my tiny essay and go to the menu, config, frequency, no, not this one, and measure, no, not this one, display, no, not this one, frequency, start, stop, no, that's the, okay, now I got into menu. The switch to high out, low out and high out. I'm going to be using the high output first, and then I'm going to be stepping down less than that. So the high output currently is off. Now I turn it on, and wait a minute, why am I getting trace 1? Let me turn off trace 1. There you go, trace 2. And the frequency is currently at 300 megahertz. I don't think it will measure that, so let me step it down a little bit now. Oh, that's right, the high output starts at 300 megahertz. So let me switch to low output. So now you go in here, high output off, and then click on somewhere else. How do I return to this mode? Switch to low output and then turn it on. There you go. Now this is at 10 megahertz, and I can adjust it so that scale it's off the screen. So let me set the level. Let me start from the beginning and see if I can measure at 1 times hertz. That's 1 hertz. So I see some ripple here. That's okay, it's in the noise floor. So now if I go to frequency and then 20, 30, let me set it to auto and see if I can find any signal. There you go. So that's 30 kilohertz, and it's not actually a true sine wave as such, but let me analyze that. And dBm. So let me select the digital voltmeter, and I get a run stop. Let me clear this. Let me go to measure. Vmax, Vmin, peak to peak. Cursor. Let me cursor. Turn off cursor. The intensity somehow is set to operation as disabled. So I can turn down the intensity, and that's how it looks like. We are measuring, let's see, measure voltage peak to peak. This is at 247.44 millivolts peak to peak. So that's that. And period, analyze, no, not this. Let me go back here to default, rising edge and falling edge. Let me turn up the intensity just a little bit. It's not a pure sine wave. The fall time is basically 11 microseconds. Minimum is 10 microseconds. The maximum is 11.256 microseconds. So I think I'm getting a good signal. I can use the tiny SA as a signal generator to measure some of the circuits device under test, and the oscilloscope as a display. So that's it for now. I'll catch you in the next video. This video has gone on pretty long enough, 8 minutes, but I give it a thumbs up. So again, the frequency is 30 kilohertz, and I'm able to see the display on my Oscilloscope. Thanks for watching.